So, good evening, sir and classmates. So, we are the group 9. And I'm the first reporter for the night. So, and our topic is about the radar plotting or manual. So, the course outcome is to this topic will give more information with regards to radar plotting. And the learning outcome is at the end of this session subject, students will collect some knowledge about radar plotting. The importance of the topic is to provide learning the basic theory and use of radar for those who will be in charge of navigation or watch. So first, what is plotting? So plotting is the graphic displaying of an encounter between observer or on ship and one of or more vessels, targets, all within the radar range of each other. So, and plotting will be done on radar plotting sheet or on refraction plotter made of plastic or glass, and primarily it is done to determine if risk of collision exists, and secondly, where it is found that such risk exists, it is used in an effort to determine the proper and sensible actions which could be taken to avoid casualties. So, radar motion display, an actual or true motion, so is expressed in terms of direction and rate movement speed relative to the earth. So this slideshow makita atong we can see that there are true vectors and true vectors of the ships. So relative motion are also expressed in terms of direction and rate of movement of one moving vehicle to another subject. So the latter being either stationary or moving, it is the combined effect of apparent result of viewing one moving vehicle against another subject or object. And subconsciously, we estimate the apparent speed and direction of other distances or vehicles, or directions of relative motion and speed of relative motion, and adjust our own true direction and actual rate of travel to avoid collision. So, this is a relative motion between two ships. Example. Next slide is the radar plotting sheet sample. Motion of ship relative to ship A, and motion of ship A relative to ship B. Second, the other figure is the actual heading of the ship. So you can see that the ship movement. Then the figure, in this figure, we can see that the relative velocity vectors, so relative vectors or rate and direction of movement of ship M relative to ship R. And kinds of plotting. So first, the manual plotting, it is done manually. And second, two main subdivisions. So a branch is the transfer plotting, or radar information are transferred to maneuvering board sheets or radar plotting sheets. So the second division is the direct plotting. So it is done right on a special plastic or glass surface over the PPI, or provided the radar set as a reflection plotter, using grease pencil to construct the plot. So these two pictures are the example of plotting sheets. So maneuvering board and radar plotting sheet. So that's all.
Automatic plotting is accomplished by self-acting digital data processing equipment which is interfaced with the radar and provides audible and visual threat detection, graphic display or plot and readouts of the parameter of the problem, such as CPA, context true course, context actual speed. So the major two types. Number 1, automated system. Use computers to process the raw data. Number 2, image retention system. Use either high persistence cathode ray tubes or electronic devices such as video recorders and playback. These systems have the capacity to retain past positions of contacts. So as seen in the picture, so relative radar plotting systems and the vector triangle. OC or own course, true course, the speed of ownership OS is also noted. E, point of origin of the ownership vector and the target vector. R is the target's ship first observation, initial position of the contact. This is pointed by the true bearing, range, and time of observation. If relative bearing is taken, change to true bearing. So M, target ship designation. Target's true bearing, range, and time. The end of the target's relative movement of the first vector triangle. The end of true course target's course vector triangle. RML or relative motion line. Line connecting R to M. This is the target's relative movement in relation to own shape. This is not the true course of the target. DRM or direction of the relative motion. Line always is the direction of the R to M. CPA or closest point of approach. The point where the target will be at its nearest distance to own ship. Bearing of CPA is the true bearing when the target is at CPA. This is perpendicular to the RML from the center. This can be computed by adding or subtracting 90 degrees to the DRML. TCPA, time at CPA. NCPA, new closest point of approach. This is the desired distance the own ship wants to clear the target. So SRM, relative speed of the target, not her actual speed. This is the rate of the or speed at which the contact closest to own ship. SM, actual target's true speed. This can be computed by measuring the scale, magnitude, or length of the vector E to M and apply the time interval between R to M. CM or true course of the target. This is found by transferring the E to M to the center and reading the corresponding degrees on her direction. NRML or new relative motion line. After deciding the desired new closest point of approach or NCPA or the radius of the desired danger circle, draw a line from the point of execution or MX tangent to the NCPA or MX or point of execution. Additional vector triangle. After establishing the ERM vector triangle, deciding the point of execution or MX, also the desired passing distance of the target NCPA, draw the NRML, and own ship will decide the course of action to take and method to be employed for the collision avoidance. For these solutions, additional triangle vector diagram is plotted as follows. ER1 or M vector triangle. ER1 shows the direction and speed of own ship to avoid collision. Transfer the line through to the center will show the corresponding true course of own ship. R1M shows the new relative direction and speed of the target ship. Transfer the line to the center to show the corresponding degrees for the direction of NRLM. AC or collision avoidance course. AS or collision avoidance speed. ROCS, or resume on ship course and speed. Vector triangle diagram, or speed vector and speed triangle. The speed vector are pictures of motion taking place. They have two properties: direction of motion and speed of motion. The vector diagram is made up of 6 factors. Number 1, OC, or the direction from E to R. Number 2, OS, or length from E to R. Number 3, CM, or direction from E to M. Number 4, SM, or length from E to M. Number 5, DRM, or direction from R to M. And lastly, number 6, SRM, or length from R to M. So the target angle, or TAN, is relatively bearing measured from CM in a clockwise direction to TBO, or true bearing of ownership, as observed from the target vessel, 6 to 360 degrees. So the formula is TAN equivalents to TBO minus CM. So it's shown in the diagram. So next slide is target aspect, or TAS, is a relative bearing measured from CM to TBO, either port or starboard, from 0 to 180 degrees. TAS is red if TBO is on the port side of the contact. TAS is green if TBO is on the starboard side of the contact, and is what I've shown in the diagram. Rule for getting TAS, or if tan is less than 180 degrees, then TAS is equal to tan, naming it green. If tan is more than 180 degrees, then tan is equivalent to 360 degrees minus tan, naming it red.
Collision avoidance methods. Method 1 is change course, maintain speed. Method 2, maintain course, change speed. Method 3, simultaneous alteration of course and speed. So, collision avoidance, the procedures: determine time of collision, TCPA, determine vessel's status in accordance with the international rules of the road. Third, call the captain. Fourth, execute transfer plot to make document on the situation. Plan when to execute the maneuvering 4 to 6 miles. Establish passing distance, or NCPA. So, special cases, no vector triangle form. So, ERM on ship course, same as target ship, but target ship is faster on ship. Speed and direction of relative movement is equal to that of own ship. Second, ERM is equal on ship course, same as target but on ship. Speed as faster, relative movement direction is opposite to that on ship. Third, MER is equal to on ship and target ship, same speed but in opposite course. Relative speed, on ship speed plus target speed, but direction is opposite to that of on ship. Fourth is ERM is equal to on ship is stationary while target is moving, relative speed and direction equals target course and speed. Fifth, ERM is equal on ship moving while target is stationary. Relative speed of target is same as that of on ship but in opposite direction. Number 6, REM is equal to on ship is moving at same course and speed is as target, relative motion is 0 or NIL, target will appear fixed on PPI of ownership. Number 7, MRE is equal to ownership and target are both stationary and therefore relative motion is NIL. So, the clarification of radar contact in a risk of collision situation, the true compass direction of relative movement must be changed. Simple rules for rapid prediction of the change is that in the compass direction of the DRM of a radar contact resulting from a course or speed change by ownership can be invaluable, particularly in the multiple contact situation. The rules can be used only when using a stabilized relative motion display. Using an unstabilized radar display could be very dangerous since a high degree of compass orientation is required to avoid risk of collision. Preferably, the radar scope should have high persistence. Through brief inspection of DRMs of several contacts on the radar scope with respect to the direction of the hidden flash, a contact can be classified as being up to scope if its relative motion is in the same direction as the hidden flash down the scope, if its relative motion is in the opposite direction to the hidden flash and crossing the scope, if its relative motion is at right angles to the hidden flash. Rules of course change. The rules provide predictions of how contact relative plot and DRM will change as a result of course change by ownership to the right. If course change is to the left, the opposite effect can be predicted, valid irrespective of the position of the contact in range and bearing. So rules for course change. Up the scope is equal to the relative plot will curve to its left when ownership turns to the right. Down the scope is equal to the relative plot will curve to its right when ownership turns right. And lastly, across the scope is equal any change of ownership's course left or right will have little effect on the DRM until the contact classification is changed to either up or down the scope contact.
Rules for speed change. The rules forecast how a contact's relative motion varies as the speed of the ownership changes. Reduced speed is when ownership slows down or stops, the relative plot moves up the scope. Increased speed is the opposite of the reduced speed because when the ownership slows down or stops, the relative plot moves down the scope. Application. When the contact is quicker than the ownership, the evasive action of the ownership has a smaller impact on the compass direction of relative movement than if the ownership were the faster ship. In both up the scope and across the scope scenarios, the contact is quicker than the ownership. When employing the DRM technique to make maneuvering decisions, speed information on a ratio basis is sufficient. The observer simply needs to know whether the contact speed is around half, 3/4, or twice the ownership speed. So here in the next slide is the illustration for up the scope. The next slide is illustration for down the scope. The next across the scope. And slide 51 is reduced speed. Next is stop. Increased speed illustration. So those are the illustrations. Time vector, minutes rule to find the speed and distance. 6 minutes rule, speed equals distance times 10, distance equals speed divided by 11. The 10-minute rule, speed equals distance times 6, distance equals speed divided by 6. 12 minutes rule. Speed equals distance times 5. Distance equals speed divided by 5. 15 minutes rule. Speed equals distance times 4. Distance equals speed divided by 4. 20 minutes rules. Speed equals distance times 3. Distance equals speed divided by 3. Last is the 30 minutes rule. Speed equals distance times 2. Distance equals speed divided by 2. Rule 7. Risk of collision. A. Every vessel shall use all available means to determine whether a risk of collision exists. In case of doubts, the risk is considered given. B. If radar equipment is present and operating, it should be used appropriately, such as long-range scans for early warnings of collisions, radar recordings, or equivalent systematic observations of detected objects. C. Assumptions shall not be made on the basis of sparse information, especially sparse radar information are not accepted. D. In determining if risk of collision exists, the following considerations should be among those taken into account. Such dangers exist when the compass orientation of the approaching vehicle does not change significantly. Such risk may sometimes exist when an unpredictable bearing change is evident, particularly when approaching a very large vessel or tow, or when approaching a vessel at close range. Rule 8. Actions to avoid collision. A. Any measures taken to avoid collision, if the circumstances permit, must be aggressively, timely taken, and taking into account the observance of good navigational rules. B. Any alteration of course and or speed to avoid collision shall, if the circumstances of the case admit, be large enough to be readily apparent to another vessel observing visually or by radar. A succession of small alterations of course and or speed should be avoided. If there is sufficient sea room, alteration of course alone may be the most effective action to avoid a close quarter situation, provided that it is made in good time, is substantial, and does not result in another close quarter situation. D is to avoid action to avoid collision with another vessel shall such as to result in passing at safe distance. The effectiveness of the action shall be carefully checked until the other vessel is finally passed, and if necessary to avoid collision or allow more time to assess the situation, a vessel shall slacking her speed or take all way off by stopping or reversing her means of propulsion. This is the illustration of the lookout zone. 8 to 12 miles is assessment, 48 miles action zone. Danger zone is in 4 miles, and what do we determine at the assessment zone is the CPA and TCPA, CM and SM. And the third is the status of vessel in accordance with Call Reg 72.